students, hope you are doing good. I am Dr. Ravi. I am going to teach you zoology, and today we are going to discuss on important topic, that is polarization and depolarization in neuron. First of all, we would like to know what neuron do. You know, neuron is responsible for the generation and the conduction of the nerve impulse. Now, what this nerve impulse is? Nerve impulse is simply a way of depolarization. You know, in neuron, different electrical events take place, and these electrical events are the result of the differential permeability of membrane of the neuron to sodium and potassium. You know, when we talk of a neuron is bathed in extracellular fluid, and this extracellular fluid has cations and anions, like it has sodium, it has potassium, it has chlorine, and cytoplasm of neuron also has cations and negatively charged proteins. The cations in the cytoplasm include sodium and potassium. So, for understanding how the electrical events, the important electrical events like polarization and depolarization take place in the neuron, for that we have to understand a little bit about the membrane of the neuron. There is something important in the membrane of the neuron. You see here, this is a neuron, and in this you will see here is a transporter that actually transports sodium and potassium. And this is called sodium potassium pump. Besides this, there are sodium and potassium voltage gated channels. Look here. This is a part of neuron membrane. You will see here in this diagram. These are the channels, like sodium channels, these are the potassium channels. Now, you see how polarization takes place. It is because of these voltage gated channels and sodium potassium pump. Now, how they work, how they are responsible for polarization, and later we will see for depolarization. Now, first we will understand polarization. You assume a neuron in a resting state, that is, it is not conducting. What happens when a nerve is not conducting, when a neuron is not conducting? You see here, this is a neuron, and you see here, it is the magnified image of the neuron here. You see here are the channels. During resting state, what happens? Sodium ions are in high concentration outside and potassium are in low concentration. But inside, potassium is in high concentration and sodium is in low concentration. You know, during the resting state, some potassium ions, they leak out and move outside. But there is sodium potassium pump. What it do, it transports 3 sodium ions from inside to outside for 2 potassium ions from outside to inside, actively by using an ATP molecule, and as a result, outside of the plasma membrane becomes positively charged charge in proteins. So net charge outside is positive and net charge inside becomes negative. So a polarity is created, developed between the surface of the neuron and the inner surface of the neuron, and this development of the polarity is called polarization of neuron membrane, or you can say the membrane is in a polarizing state. Now see here, inside is negative and outside is positive. So there is an electrical potential difference, or you can say simply there is a charge difference, and the charge difference or the electrical potential difference in this case is called resting potential or resting membrane potential, because the neuron is in a resting state. Now the resting potential is minus 70 millivolt. You see here, this is actually a membrane in the resting state, and the sodium and the potassium channels are actually closed. You see here, it is minus 70 millivolt. Now, when a threshold stimulus with a value of minus 55 to 60 millivolt is applied to the neuron, what happens? The sodium channels open. Look here. Here, when this threshold stimulus is applied, sodium channels open and sodium rushes from outside to inside, from the higher concentration to low concentration, that is down the concentration gradient, and positive charge moves inside. But you see here, the potassium channels remain closed. So at a certain point of time, what happens? The inside becomes positively charged and outside becomes negatively charged. This change of, we can say, the membrane potential. This change in the membrane potential, that is from minus 70 towards 0, it is called depolarization. That is reverse of the polarization process. Here you see this part, inside is positive and outside is negative because of the influx of the sodium. So it is called a depolarization. But this, the point of stimulation sends signals to the adjacent parts, while yet depolarization has not taken place. Due to this signal, or due to these signals, what happens in the adjacent parts? Sodium channels are open and a wave of depolarization moves. You see here, the wave of depolarization in this case is here, then it moves to here, and you see the electric potential goes from minus 70 goes to 0, then it moves to plus 30 millivolt. And when it moves to plus 30 millivolt, you see here, it's called action potential. And this plus 30 value is called action potential P. Now, after some time, when the wave of depolarization travels, what happens? Sodium continues to move during the depolarization, but at a certain point of time, sodium influx slows down and stops. But at the same time, what happens? The potassium ion channels, they are open. When they are open, you know, potassium concentration inside is high and outside is low. So the potassium ions flow from inside to outside. So now the positive charge is moving from inside to outside. So at certain point of time, you see outer membrane, or you can say outer surface of the membrane becomes positively charged and inside becomes negatively charged. It means that again at the resting potential, you see it is called, there occurs, we can say repolarization. Like you see in the resting potential, outside is positive and inside is negative. Again here in the repolarization, you will see that due to the flow of potassium from inside to outside, outside becomes positively charged and inside becomes negatively charged. So this is called a repolarization. You see here, it means that when the repolarization begins, the electric potential will drop from plus 30 to minus 70. You see, here in the repolarization it drops to minus 70. That is, the resting potential is regained. Then repolarization occurs. But sometimes dear students, what happens that excess number of potassium ions move outside and outside becomes highly charged and the potential, the membrane potential drops below 70, say to minus 80, then it is called hyperpolarization. So in this way, due to these electrical events, a wave of impulse is generated and conducted along the membrane of the neuron, and through repolarization the neuron membrane is restored to its original state. So this is how nerve impulse is generated and conducted. Dear students, I hope you understand the topic well. We would like to sum up the topic briefly, that the electrical events like polarization and depolarization are the important processes that are responsible for the generation and the conduction of nerve impulse with the help of sodium, potassium, these channels, as well as with the help of sodium potassium pump. Dear students, at last I would like to ask you a practice question. The question is, the value of threshold potential is option A plus 30 millivolt, option B minus 70 millivolt, option C minus 55 millivolt, and option D 0 millivolt. Yes, anyone? You? Yes, you are right. It is minus 55 millivolt. Dear students, I hope